Hey guys, we're continuing same section we were working on yesterday. Trig functions of any angles, except that we're going to introduce a few identities. That's the new part, so let's hit it. Here they have big identities. You know the first set already. These are called reciprocal identities, and they're just telling you which trig functions are reciprocals of which one. Cosecant reciprocal of sine, secant reciprocal of cosine, and these are vice versa, by the way. Cotangent reciprocal of tangent. Tangent's also sine over cosine. And we use that one a lot. And cotangent is cosine over sine. Now these next three are called Pythagorean identities because they're based on the Pythagorean theorem. That first one, remember when we did these angles last week and we were talking about the sine is the x, like if the angle is right here, we said, that's the x, that's the y, and then you run into a point up here, and we said the cosine is the x, sine is the y. Well, if it's a unit circle, if the radius is 1, obviously if we did x squared plus y squared equal 1 squared, or just 1. So that's kind of where it comes from. But sine squared plus cosine squared is 1. If you substitute reciprocals from up top, you can come up with this one. Tangent squared plus 1 is secant squared. Also substituting again, you can come up with 1 plus cotangent squared is cosecant squared. So write those three down. We're going to use those three, especially that first one, over and over and over again. And just as expressing one trig function in terms of another, part A says let's write sine in terms of cosine. Okay, just remember we just found out that sine squared theta plus cosine squared theta is 1. So if I'm going to put sine in terms of cosine, I'm trying to get the sine function by itself. Sine will be 1 minus cosine squared theta. And then to get sine, I'm going to take the square root of both sides. Don't forget your plus or minus. So sine is plus or minus 1 minus cosine squared theta. And that's sine in terms of cosine. The second part B, says express tangent in terms of sine. Okay, tangent, remember from the last slide, tangent sine over cosine. All right, now the problem here is I just need sine. And also it tells me it's in quadrant 2, which means sine is positive, cosine is negative. Now, just like we just did, we just found out a second ago that sine is plus or minus the square root of 1 minus cosine squared. It also is true that cosine is plus or minus the square root of 1 minus sine squared theta. And I would have it right there. That's tangent with only in terms of just sine. But because it's in quadrant 2, remember cosine's negative in quadrant 2. So when I wrote that plus or minus, I've got to determine which one it is. And because it was cosine and cosine's negative in quadrant 2, I just need the negative right there. Hope that makes some sense to you. We'll work on some of these tomorrow, obviously. All right, this one says if tangent is 2/5 and x is in quadrant 3, find cosine x. Okay, so what we learned a minute ago on the identities was the tangent squared plus 1 is secant squared. Okay, and I like that one because secant squared and cosine are reciprocals of each other. So I can find secant, I can find cosine by just taking the reciprocal. So I'm just going to plug this in. Tangent x is 2/5. If I square 2/5, you get 4/25 plus 1 is secant squared. If you add secant 4/25 and 1, you get 29/25. Take the square root, and you get plus or minus the square root of 29 over 5. Now, it's not really plus or minus because it tells you actually what quadrant we're in. We're in quadrant 3. Cosine and sine are both negative in quadrant 3, so secant is negative square root of 29 over 5, which means cosine of theta is going to be negative 5 over square root of 29. You need to rationalize that denominator. Get negative 5 on 29 over 29. All right, one cool application of all this is finding areas of a triangle. We have one last rule of theorem here. It says the area of a triangle with sides of A and B and the included angle. Now, if you remember this from geometry, it must be this condition. It must be side, angle, side. If you look at the picture down here, like this side's 3, that side's 10, the angle's in between those two sides. So you really have an SAS situation, and I hope you remember that from your geometry. The angle must be in between the two sides that you have to use this. So the area is just this, just 1/2 AB sine theta, and it works because it's really 1/2 base times height, which you'll find out when we do law of sines later. But that's really what that is in trig language, okay? So here I go. I'm just going to say area is 1/2 of A. Doesn't matter which one's A and which one's B. 10 times 3 times sine of 120. Now, 120 is one that we should know because the reference angle is 60, and it's in quadrant 2. So if you work that out for sine 60, you get square root of 3 over 2. And it's positive because sine is positive in quadrant 2. All right, so if I'm going to follow that out right there, half of 13 is 13 over 2. Half of 30. Half of 30 is 15. So it's going to be 15 times square root of 3 over 2. Sorry about that delay right there. And I get 15 on 3 over 2 for the area. 15 on 3 over 2. All right. Going through that pretty quickly, quite a bit of stuff. You need to make sure you have those identities down. Make sure you have this area of a triangle formula written down. And that's pretty much what we're doing tomorrow. So see you then.